Unit 4A, Lesson 3. In this lesson, we're going to discuss experimental and theoretical probabilities, and then we're going to use those ideas to try to determine whether or not a model or experiment was fair. The first term to discuss is theoretical probability, which is the probability calculated based on mathematics. That is what we expect to happen given a certain situation. The experimental probability is a probability that's calculated based on an actual experiment. It's what actually happens after you go through and run a model. The thing to remember between the two is that the experimental probability usually becomes closer to the value of the theoretical probability if we conduct more trials or runs in the experiment. Now to the first example. The students in Danny's math class are each given a 6-sided die. Some of the dice are weighted and others aren't. The students aren't told which ones are. Their assignment is to roll the die 100 times and record how many times an even number was rolled and how many times an odd number was rolled. From their results, they are asked to predict whether their die was weighted. So use Danny's results to predict whether his die was weighted or not. We could see the results of Danny's 100 trials to the left. He rolled even numbers 46 times and odd numbers 54 times. So what we're going to do is calculate the theoretical probability and the experimental probability, and then compare those results to determine whether or not we think his die was weighted. So first, calculating the theoretical probabilities. If we think about a 6-sided die, how many even numbers are there on a 6-sided die? There are 3. So we have 3 over 6, which we could simplify to 1/2, which is equal to 50%. Same thing if we're looking at what is the probability of rolling an odd number. Well, a 6-sided die, there's 3 odd numbers, which we would reduce to 1/2, which is equal to 50%. So the probability of rolling an odd number or an even number with a 6-sided die is going to be 50-50. Now we want to go through and calculate the experimental probabilities. First, if we calculate the probability of rolling an even number based on his experiment, an even number was rolled 46 times out of 100 trials, which we could just write as 46%. Using the same idea for the probability of rolling an odd number was rolled 54 times out of 100 trials, which we could just write as 54%. Now we want to compare the theoretical and experimental probabilities to see if they're reasonable. So the probability of rolling an even number, 46 compared to 50, that is not too far off. The experimental results are fairly close, are reasonable when comparing to the theoretical. Same for the odd. So in my opinion, I would say that the die was not weighted. If he would run more trials, run this experiment another 100 times, it's just as likely that he would roll an even and odd number 50% of the time. So the die is not weighted. This would be a fair experiment. And if you notice my grammatical mistake in this problem, good for you. The next problem. Susie has a chance to win a prize in her class. She gets 10 tries to get a 6 on the spinner. After 10 tries, she failed to get a 6. She complains that the spinner is somehow unfair or rigged. Do you agree with her? Okay, so I want you to go through this, calculate, think about what the theoretical probability was, think about her experimental probability. Do you think this spinner is somehow rigged or unfair? Come up with your results. We'll discuss these in class. To end this lesson, there's some questions I want you to consider. First one, could the results of an experimental probability be significantly different than the theoretical probability? The second one, what factors can help ensure an experimental probability will be close to the theoretical probability? So for class, I want you to have your answer to Susie's question. Do you agree or disagree with her, and be able to defend that, as well as be able to answer and discuss these two questions.